Let's now look at question 11 that focuses on a firm operating in a perfectly competitive market. And so if a firm operates in this type of market, it means that it is a price taker because it is producing an identical product to its competitors' products. Okay. So using this information or using this assumption, we're going to see which of these statements below don't fit with the definition of a firm in perfect competition. So A says there is no profit incentive for this firm to charge a price higher than the equilibrium price. This is a correct statement because, as we've already mentioned, this firm is producing an identical product to that of its competitors. And so if this firm charges a price higher than the market price, which its competitors will be charging, it then risks losing its customers to its competitors. So you can actually relate this to elasticity, which I know comes a bit later in this unit. But what we know about a perfectly competitive firm that is a price taker is that it faces a horizontal demand curve. This horizontal demand curve represents perfectly elastic demand. So elasticity is some really large number, close to infinity. If we think about what this means, it means that the percentage change in quantity over the percentage change in price is some really large number. If you increase your price by even a little bit, so let's say 1%, it means that your quantity demanded is going to fall by some really large value. So let's say 100,000%. So even increasing your price by a little results in a massive decrease in your quantity demanded. And so yes, there is no profit incentive for a firm like this to charge a price higher than equilibrium price that is set in the market because it risks losing most, if not all, of its sales. So in the context of this question, which is looking for an incorrect answer, this is not the statement that we are looking for in the context of an incorrect answer. B says this market is efficient, but the outcome is not necessarily fair. So a perfectly competitive market does produce an efficient outcome. And the reason why is because the willingness to pay of the marginal buyer equals the willingness to pay of the marginal seller in equilibrium. And so if all units up to this equilibrium quantity are bought and sold, in other words, traded between buyers and sellers, then we are able to exploit all of the positive gains from trade. So these vertical distances here represent the positive joint surplus of trade between buyers and sellers. If we had to go beyond this point, then that surplus would become negative, and then we would actually be seeing a decline in total gains from trade in this market. So it is true that this market is efficient, yes. The second part of the statement says, but the outcome is not necessarily fair. That is also true. And so there are two reasons why perfectly competitive markets don't necessarily guarantee fair outcomes. And the one reason is because surpluses may not be fairly distributed. So just to kind of give you an example, let's say that supply is quite elastic, so the supply curve is flat, and let's say that demand is quite inelastic, so it's very steep. This would be the market equilibrium. This area below the equilibrium price would be producer surplus, and this area above the market price would be consumer surplus. And so even though this equilibrium outcome here maximizes total surplus in this market, in other words, consumer surplus plus producer surplus, we see that the consumer surplus far exceeds the producer surplus. Another way in which these markets don't guarantee fairness is because only those buyers with the willingness and ability to pay, and those sellers with the willingness to accept, in other words, the necessary capital to set up in this industry, will participate. And so it really depends on the distribution of resources in society who would actually be able to take advantage of any gains from trade in this market. It may be that there are very few people with the ability to pay for products, and there may be very few people with the ability to set up as sellers with a certain willingness to accept in this market. So this is why, although these markets are efficient, they are not necessarily fair. So this is a true statement, which means it is not correct in the context of this question, which is looking for an incorrect statement. C then says, the firm will produce where its negatively sloped demand curve intersects a positively sloped marginal cost curve. This part of the statement is incorrect. As I drew down here, these firms that are price takers face horizontal demand curves, which are also their marginal revenue curves. And so facing an upward sloping marginal cost curve, they produce where the horizontal demand curve intersects a positively sloped MC curve. So this is an incorrect statement, which is why it is the correct answer to this question. And then just to check that D is correct, making it wrong for this question. Total surplus is maximized in this market. That is exactly what I explained down here. So this is true, making it wrong in the context of question 11. I'm then going to move on to question 12, which continues with this theme of perfectly competitive firms and perfectly competitive markets. And what the question says is, which one of the following statements is true? So now we're looking for a true statement regarding a firm that operates in a market where many firms produce homogeneous goods. So homogeneous is just another term for identical. And so in markets where there are many firms producing identical products, this is a perfectly competitive market, which means that firms are price takers. So A says, the firm will exit the market if they make zero economic profit. So zero economic profit is also referred to as normal profit. And zero economic profit represents a positive accounting profit. So the accounting profit is greater than zero. So making zero economic profit doesn't mean you're breaking even in accounting terms. What it means is that you are making the profit that is expected from the return to the capital investment. In other words, you are making exactly what you expected to make as a return on the investment of setting up this firm in this industry. If your economic profit was greater than zero, then it means you're making more than normal. In other words, this capital investment and the risk taken in investing your capital here has produced greater than expected returns. And if your profit is less than zero, then you're making less than normal. And so the investment of your capital in this industry has returned less than expected. So that's how we interpret economic profits. And so if you're making zero economic profits, it means that you are making exactly what you should have expected to make as a return on your capital investment. And so you won't exit the market. Firms will only exit the market if they are making economic losses. But then specifically, it has to be a loss that exceeds the total fixed cost of production. So what do I mean by that? What I mean is that if, let's say, your total cost function is given by this. So this is the total cost of producing. This 10,000 here represents the fixed cost of production. And the reason why it represents the fixed cost of production is because if you produce nothing, in other words, if you aren't producing, you still have to pay your fixed costs. When you produce nothing, that is the same as saying that you just close your door for the day. So it's not like you're exiting the market, you're just shutting down operations. Because the idea being that if you stayed open, you may make a loss that is larger than the fixed cost of producing. So we argue that the total fixed cost is the maximum loss that a firm would be willing to bear, because if they stayed open and they made a loss that is larger than this, it would have been a better decision to not be open and produce nothing. So if your loss exceeds this amount, it means that staying open is costing you. And if this situation continues long enough, you would then exit the market. So firms only choose to exit the market if they make economic losses that don't justify staying open. So this is a false statement, which is why it is not correct for this question, because we're looking for a true statement. B then says the average cost curve of the firm is the supply curve. This is false. This should say the marginal cost curve of the firm is the supply curve. That would be a true statement. C then says there are unexploited gains to trade if production occurs where marginal revenue is greater than marginal cost. So how would that look in a picture? So price-taking firm faces a horizontal demand, which is also its marginal revenue, and this is set at the market price. They face an upward sloping marginal cost curve, which is also their supply curve. And they profit maximize where these two are equal. So where marginal revenue equals marginal cost. If you are producing where MR exceeds MC, what that means is that you are producing somewhere below the profit maximizing quantity. If you had to produce and sell all of these additional units, you are able to make marginal profits on each of those units, because what you would get in revenue from that unit would exceed the cost of producing that unit. And so all of these vertical distances represent unexploited gains to trade. So this is a true statement and makes it the correct answer to this question. But then just to confirm that D is in fact incorrect, the firm will set its own price. That is false. It is a price taker. So the answer to question 12 is C. We now move to question 13, which tells us that a competitive firm is currently earning zero economic profits. In other words, this competitive firm is making normal profits. Suppose there is then a decrease in market demand. This firm is then likely to increase the quantity of output it produces. True or false? So I'm going to represent the situation in two graphs because that's going to help you see where the answer comes from. So I'm going to draw a perfectly competitive firm next to the market in which it operates. So we have price and cost for the firm on the y-axis here, and we have price in the market here. Then we have the quantity of the firm and the quantity in the market. So I'm just distinguishing the firm's quantity using a small q and the market quantity using a capital Q. So the market faces downward sloping demand and upward sloping supply. So the market is going to find equilibrium where these two intersect, and that's going to give us the equilibrium price and the equilibrium quantity. This firm is a price taker, which means it has to take this market determined price as given. And so this is going to be the firm's demand and marginal revenue curve set at this equilibrium price. So this is given. The firm has no choice over the price it sets. But it can choose the quantity it produces in order to maximize its profit. So we compare this demand and marginal revenue curve to the firm's marginal cost. And we would say that this firm profit maximizes when it produces this quantity where MR equals MC. In order to show that this firm makes a zero economic profit, that means that price must be equal to average cost at the quantity that is being produced. So in terms of this picture, if this is the quantity that's being produced and this is the price they're having to charge, for normal profit, then average cost must be equal to this price at this quantity. And because our average cost curves are U-shaped and its minimum is where MC cuts AC, our AC curve is going to look something like this. So it's going to sit on top of the demand curve, and its minimum point is going to be here where the MR intersects the MC. This describes a perfectly competitive market and firm in long run equilibrium. In long run, competitive firms are only able to make zero economic profits because if they make positive economic profits, in other words, they make more than normal, then this would be an incentive for firms to enter the market in order to take advantage of these super normal, so above normal profits. So they are restricted to making break even or normal profits in the long run. There is then a decrease in market demand. So I'm going to label these S1 and D1 to represent the original supply and demand. So demand decreases, which means it shifts to the left. And that's going to put downward pressure on price and quantity. And so the quantity in this market drops and the equilibrium price in this market drops. So we move from this long run equilibrium to a short run equilibrium at E2. And you'll see now why this is a short run is because now the firm can no longer charge this price 1, so the equilibrium price 1. It has to take the market price as given. And so its demand and marginal revenue curve are going to shift down to be at this new equilibrium price. Okay. So because of the lower demand in the market, the firm's demand curves shift down. Nothing is going to happen to this firm's costs because nothing is happening on the cost side. And so this firm now can no longer produce this quantity and profit maximize. It would profit maximize here where MR equals MC. And so this is going to be the new quantity that it produces in order to maximize profit. Now, some of you might be looking at this picture and notice, okay, but how can that be profit maximizing if in actual fact, at this quantity, this firm is now making a loss? And you're absolutely correct. Profit maximization is synonymous with loss minimization. So this firm, having to take this new lower market price as given, has no choice but to charge that lower price. And so, in order to minimize its losses, it chooses to produce less. So the response of this perfectly competitive firm to a decrease in market demand is not to increase their quantity, but to decrease. And so the answer to this question is false. Question 14 deals with the same sort of scenario. So we get given the marginal cost of production and the market price for a firm in perfectly competitive market in long run equilibrium. So again, what does long run mean for this firm? It means they make zero economic profits or normal profits. In other words, their price and average cost are the same. Question A, asks us to define the concept of marginal revenue. So what is marginal revenue? Marginal revenue is the additional total revenue made, so the change in total revenue, when one additional unit is produced and sold. So if we had to put this into mathematical terms, MR is the change in TR over the change in Q, where the change in Q is typically 1. So that is marginal revenue. B then asks us, what is this firm's marginal revenue? And briefly explain your answer. So the market price is 50. And we know from the previous question that this gives us the firm's demand curve and their marginal revenue curve. So if the market price is 50, it means the firm has to charge 50 Rand for every unit it sells. And so its marginal revenue will be 50. And this is because the price equals marginal revenue. Okay, so it takes this price as given, it has to charge exactly the same price for every unit sold. So every time it sells one more unit, it makes exactly 50 Rand every single time. C then asks, what is this firm's average cost? Briefly explain your answer. So if this firm is in long run equilibrium, it makes zero economic profits, which means it has to be charging a price that is equal to its average cost. And if it is charging a price of 50, that must mean its average cost is 50. That is the only way it's going to break even in economic terms on each of its units sold. Briefly explain your answer. So in long run, price equals AC. Okay. Explain why the firm earns the maximum possible profit when it chooses to supply a quantity of 100. So if we go up to the picture here, here's a quantity of 100. If we read up to this point here, we see that 100 is the quantity where MR equals MC. And so what we can say is that when Q equals 100, marginal revenue equals marginal cost. This is the point at which maximum profit is made. So MR equals MC is the profit maximizing rule. If it had to produce a quantity that is below 100, then it would lose out on additional profits per unit. And if it made more than 100 units, then it would be costing it more than what it can get in revenue from each additional unit. And so exactly at this point where MR equals MC is where profit ends up being maximized. Okay, so then E then asks, if this firm and only this firm were to discover a new technology that reduces its marginal cost, what would the short-run effect on the firm's quantity supplied be? Briefly explain, no graph needed. Okay, so I like to draw graphs because I think graphs are just the best way to understand where the answer comes from. So if I just replicate more or less what was on the previous page, we have this firm currently charging a price of 50 because that is the price that maximizes, that's the price that it has to take as given because it is a price taker. And it maximizes its profits when it produces 100 units where MR equals MC. Sorry, this should be MC. Now we get told that the new technology that only this firm is able to adopt reduces its marginal cost. And so marginal cost moves like this. Okay, it becomes cheaper to produce each unit. So the marginal cost curve moves like that. In other words, if they continue to produce 100 units, marginal revenue now exceeds marginal cost. That means this would represent unearned profits on each unit produced beyond 100. And so this firm actually would maximize its profits if it increases its quantity to where marginal revenue now equals this lower marginal cost, MC2. So the short-run effect on this firm's quantity supplied would be quantity increases because MR equals MC2 at a higher quantity. So this would be useful if you just drew a really rough sketch so then the marker could see what you mean by MC2. You could also say that at Q equals 100, marginal revenue would now exceed marginal cost, and so quantity would increase in order to profit maximize. Okay, so the result of this firm facing lower cost of production is that it would increase its output. Now this wouldn't affect the market because only one firm in a market of many firms having this new technology would not push the market anywhere. One firm's marginal cost curve changing is not going to change the entire market's marginal cost curve. But if all firms in this industry were able to adopt this new technology, then there would be an effect in the market. So if all firms were able to adopt this technology, then what would happen is the market supply curve would shift. So look at this picture here. The marginal cost drops, which visually is the same as it moving to the right. The market supply curve are all of the marginal cost curves of the individual firms horizontally added up together. And so if all firms' marginal cost curves are moving like this, then the market supply curve, which is the market MC curve, will also move. So what we would then say is that if the original price was 50 and this was the original market quantity, the result of this lower cost technology in this market is that the price would fall and the quantity produced and sold in this market would rise. So the effect on the equilibrium market price and quantity in the short run of this lower cost of technology is that the price in the market would fall and the quantity in the market would increase. The second part of this question then asks, okay, but then how will this firm's, so the early adopter, the first adopter of this technology, how would their quantity supplied adjust in response to these developments? So if I go back to this picture here, because its cost changing didn't shift the market at all, it meant that when it was the only one with this technology, its cost went down, but it was still able to charge 50 Rand because that's what the market price is. But now the market price is lower. And so the price that it can now charge is going to drop. So let's say the price drops to here. So this is the new price. And so this firm's demand and marginal revenue curve fall. What would happen to their quantity? So when they were the only ones with this technology, their quantity went up. But now, given that everyone else has adopted it and the price in this market has fallen, they would now profit maximize over here. And so the quantity that they would produce would fall. So the results of this technology being adopted by everybody in the market is that the market price would fall, the market quantity would rise, and the quantity of this firm would fall. So it really helps to draw graphs in order to guide your answer for these types of questions. Okay, great. So I'm going to go back to the example. So I'm going to go back to examples of monopolistic competition because I'm going to bring profit into it now again. And then I'm going to show you a question that uses a table instead of a graph. And then I'm going to show you a question finally that uses a picture of a perfectly competitive market, and we're going to look at consumer and producer surplus. So there's 3 or 4 more questions to go through, and all of them are very applied, and yeah, there's a lot of theory to go through in them, which is great. So Frankfurters is a producer of gourmet hot dogs in Cape Town. Although there are many other firms producing hot dogs, their product is different. This tells us that the firm is able to set its own price because it's selling a differentiated product. And so the demand is given by this linear function, which would give us a downward sloping demand curve. We then also get given the marginal cost and the total cost functions. I'm just checking, and I think, yes, I can see again, this should be a 1/8, and this should be a 1/16 squared. Otherwise, these don't make sense. So that's just a printing error. Okay, so what is Frankfurter's fixed cost of producing hot dogs? So fixed cost is the total cost when output is 0. And so if I put 0 in for quantities here, I get 250. So the fixed cost of producing hot dogs is 250. The next question, which is out of 5 marks, asks, what is Frankfurter's profit maximizing price and quantity? Show all your calculations. Profit maximization is found where MR equals MC. I always like to draw a little graph to help guide the algebra. So this firm would face a downward sloping demand curve and therefore a downward sloping marginal revenue curve, upward sloping marginal cost. So profit maximization is going to be where MR equals MC. And then the price that they would choose to charge would lie on the demand curve. So they would choose to charge the maximum price their consumers are willing to pay for this quantity. So I have marginal cost. I need marginal revenue. They've given me the demand function, which means I have to inverse this to get the demand curve. And once I have the demand curve, then I can get marginal revenue. So first step is to inverse this demand function. So for price equals 340 minus Q. And so price is going to be 85 minus a quarter Q. That means my marginal revenue is going to be 85, same intercept. Slope is twice that of the demand curve, so 2 times a quarter gives me a half. So that's the marginal revenue function. So if I set MR equals MC, I get 85 minus a half Q is equal to 1/8Q plus 5. I take the 5 to this side and I get 80. I take the half to this side and I get 5/8Q. And so that's going to give me a quantity of 80 times 8 divided by 5. of 128. So this quantity is 128. In order to find the price charged for this quantity, I then sub in 128 into my demand curve over here. So price is going to be 85 minus a quarter times 128. A quarter of 128 is 32, and so 85 minus 32 gives me 53. So this price is 53. Great. So those are all the calculations to find the market profit maximizing price and quantity of this firm. Question C then asks, is Frankfurters making a positive or negative economic profit? Show all your calculations. So profit is TR minus TC. Total revenue is price times quantity. So 53 is my price, 128 is my quantity. So this is going to be 53 times 128. And then to get my total cost, I sub in 128 into my total cost function there. So that's going to be 250 plus 1 over 16 times 128 squared plus 5 times 128. And so if I solve for this, my total revenue is going to be 6784, and my total cost is going to be 128 squared divided by 16 plus 5 times 128 plus 250, which gives me 1914. And so that means my profit is 4870. So this is a positive economic profit. Okay. D then asks us, do you expect there to be more or fewer firms selling hot dogs in the future? Briefly explain. Okay, so this is a monopolistically competitive market. And the reason I know that is because there are many firms selling differentiated goods. So it is a competitive market, which means if any firm in this market is making more than normal profits, so positive economic profits, it's going to incentivize other people to set up in this industry. So we would expect there to be more firms selling hot dogs in the future, because positive economic profits incentivize entry into this market. And as a competitive market, firms are able to freely enter. That is very different to a monopoly, where high barriers to entry and exit prevent new firms from coming in order to take advantage of the positive or supernormal economic profits, supernormal profits. Okay, so even though it isn't perfect competition, these firms are also limited to only making normal profits in the long run, because other firms are able to come in and compete against them for positive economic profits. Okay, great. So that's question 15. Now I'm going to move on to some questions with consumer and producer surplus and deadweight loss, because this is sort of the last part of the Unit 7 and 8 Part 3, which looks at efficiency of these types of markets. So monopolistic versus competitive markets, or to be more specific, perfectly competitive markets. So we have the table below that gives us the demand and supply schedules for a competitive bread market. So what this table represents is the demand curve and the supply curve. If I had to plot these quantity demanded against those prices, I would get a linear demand curve. And if I plotted these quantity supplied against these prices, I would get a linear supply curve. So this is just another way of representing demand and supply. So we can represent demand and supply either using a function, a mathematical function, a graph, or a table. So this is another way of testing this work. A then asks, what is the maximum price that consumers are willing to pay for the 80th loaf of bread? So willingness to pay measures how much the consumer of this particular loaf of bread would have at most been willing to pay for it. And typically we identify that using our linear demand curve. So we would say, okay, at this quantity, this price would be the maximum willingness to pay for this quantity. In the case of a table, we've got exactly the same information. So at 80 loaves of bread, we see that this is associated with a price of 14 Rand. And so that tells us that the maximum price that anyone is willing to pay for this 80th loaf of bread is 14 Rand. B then asks us for the minimum price that producers are willing to accept to produce the 200th loaf of bread. So this we would normally find using the supply curve. But we have the same information in this table. Now the tricky thing here is that 200, 160, and 240. In other words, the price that this seller of the 200th loaf is willing to accept would be somewhere between 10 and 12. So just to visualize that, if this is the supply curve, what we know is that for 160 loaves, the minimum price willing to be accepted is 10, and for 240 loaves, the minimum price willing to be accepted is 12. 200 is midway between those two. Now, because it is a linear function, that must be 11 Rand. I can also tell that it must be 11 Rand if I look at these values in the picture. What you should notice is every time quantity supplied changes by 80, it is related to a 2 Rand change in price. In other words, the change in quantity supplied for a change in price is equal to 80 over 2. So every time price goes up by 2, quantity supplied goes up by 80. And so if the price goes up by 1, the quantity supplied changes by 40. So going from 16 to 200 would be a 40 unit change in quantity supplied. And so in order to get that 40 unit change in quantity supplied, the price must increase by 1 from 10 to 11. And so that's how I can conclude that the minimum price that producers are willing to accept for this 200 loaf of bread is 11 Rand. C then asks you to calculate the consumer surplus if the market is in equilibrium. The best way to answer this is to draw it. 100% the best way. Because you need to be able to visualize it in order to use the information provided in the table. So if this is the market demand and market supply, we would find equilibrium here where the two intersect. So let's look at the table and figure out where this occurs. So the market would be in equilibrium when quantity demanded equals quantity supplied. And we see that that occurs at a price of 10. So 10 Rand is the market clearing price. It's the price that makes quantity demanded equal to quantity supplied, which is 160. How would I identify the consumer surplus in equilibrium? So consumer surplus is the area below the demand curve and above the price. So it's this triangle over there. The definition of consumer surplus is the difference between what consumers are willing to pay and what they truly pay. So for this first consumer, they're willing to pay a lot for a loaf of bread, but the market is only charging them 10. So they make a lot of consumer surplus on that loaf of bread. And then the same for the second person. They also make quite a lot. If we calculate the consumer surplus for every single consumer between 0 and 160 loaves of bread, we would get this area here. So we can now use the area of a triangle to calculate our consumer surplus. We just need this value over here to complete all the information we need. So this value here is going to be the price when quantity demanded is 0. And looking at our table, quantity demanded is 0 when price is